G'day guys and welcome back to my channel. This week I'm again working on my 1957 DoAll bandsaw. Now since I overhauled the gearbox, it's cutting nicely, but there's a few little niggly issues I need to address. Things like getting the power feed mechanism working out which belts I need to use for it, and a few other issues. Last week I did a Patreon and members live stream which explains the issues I'm going to work on today, so I figured I'll just recycle some of that footage to show you. Well, g'day guys. Thanks a lot for joining. What I wanted to talk about today, or have a closer look at today, was the drive belts and the actual belt speed. There's a belt given here for the transmission, and looking at that specification, I bought the new belt which is currently in there. There's a couple of things about that. One is, I bought one with an X in its name, not realizing that that means it's notched type of belt. I have been told in the comments section that those notches are not good for variators because they can wear in and cause like damage to the sheaths of the pulleys. I think the whole motor's now been raised up probably an inch or so, which is why you end up with a shorter belt. Although I ordered the correct length belt for it, in actual fact it's probably too long. I've got it in there at the moment because I just wanted to see, whether the correct length would work better. The reason why I suspect that this no longer needs the correct original belt length is that I don't think this motor mount's original. The motor's obviously European, Belgian or French. I'm guessing the original would have been a GE. That's pretty typical for DoAll. What I'm thinking is that one of the previous owners manufactured this whole motor mount system, which raises the motor up higher than original. The second reason I think it's not correct, it's hitting this big heavy weight which is used for manually dragging work through. It's kind of like the sort of manual version of a power feed. This should be able to go down past here, so I'm definitely going to have to cut the ears off this or make up a new base completely. So let's just start off by putting it in the slowest speed possible. So I'm suspecting that too long belt means that it's sitting below the lowest speed effectively that it can adjust. So to check that, let's see if I can work out what would be the correct belt to use. I've put a couple of markings on my blade. At the moment, the thing is set at the lowest possible speed. And what I'm going to do is just measure the time it takes to go through 2 revolutions and then try and work out what my actual band speed is, and then we'll work from there. We should be getting belt speeds from about 15 through to 90 on the low speed side. $60 divided by 14 times the 6 meters. 25 meters per minute is the lowest speed I'm getting. For whatever reason, I'm running too fast. Let's now go to the higher speed end of the range and see what sort of speed I can get out of it there. Doesn't sound like it's done much yet, has it? Okay, did you hear that kind of interference sound? At the highest speed, I'm getting interference between that bolt and this sheath. I'm definitely going to have to do something about the length of that. Doesn't need to be that long because the stop nuts are here, so everything out the end here is just wasted threads. I guess the easiest thing to do will be just cut them off. I'll run the saw and just see what sort of speeds it gives me, but yeah, to me that's pretty clearly too long, that belt. 1, 2, 3, 4, 5. That was 5 belts, 5 belt lengths worth, so 15 meters in about 9 seconds. 60 divided by 9 times 15, giving me a speed of about 100 meters if I'm calculating correctly. Would seem fast because it should only be at about 75 by that point. I just need to slow the belt back down. I'll just put it in e-stop to make sure it doesn't try and bite me. We'll switch over from this belt to the old shorter belt. That seems slower. One. Two. Okay, that's much closer to the design minimum speed of 15. Five laps gives us about 64 meters of band speed, so still well down on the roughly 90 meters it should be doing. With this being the current maximum speed, you can see this belt's still running quite deep in the sheath. The other issue could be that this belt's not the right specification in that it's too narrow. Once I chop that screw off, which will allow me to extend it a bit further up, I should also be able to get a wee bit more speed out of it. The input belt is also looking a bit worse for wear. It's got some sort of damage to it here, so I guess at the same time I'll be replacing that one. Anything else I'm not thinking about here that I need to consider to try and get this to work properly? So that's an example of one of my Patreon members' live streams. Now, if you think that's interesting, for the price of less than a cup of coffee a month, you're welcome to come and join me. I'd really appreciate it because it really helps support this channel and allows me to make these videos for you. Right, seeing as that's interfering here, I guess I need to cut it down here somewhere. I don't really understand this because from what I can tell, this is an original motor mount and that's the original counterweight. The only thing I'm kind of thinking is, did somebody pack this up and then use the shorter belt? Maybe if I just take these blocks out, lower the whole thing down and use a longer belt, it would also fix the problem. Let's start by whipping this motor out and see what happens. It looks like this cable's pulled out of its gland nut, so let's disconnect it and I'll take the whole motor out, clean it all up and then put it back in properly. Pull the power out of the wall before I get any further. So there's that little air blower there. It's just for blowing the chips away. Probably quite handy. Let's give that a good clean up and see if it actually works. Doesn't sound that good. God, it's all filthy, isn't it? Amazing the thing's still cooled at all. If you've ever been paid to do maintenance professionally, this sort of thing drives you nuts. These were the 4 bolts holding the motor's foot on. 4 of them have got a 9/16 head on them. And of course one of them didn't. You're trying to get the thing to grip with the 9/16. It's only when you get the mirror out that you find out that, of course not, it's something completely different. Since one of them's also really bent, I'll probably just replace all 4. One more thing going metric on this machine. Right, let's get this stuff clean. One of my viewers gave me some of this TR3 ultrasonic cleaning fluid. I'll throw a bit of that in. Let's see what that does to it. I already sort of scraped off most of the worst of the gunge. It comes up nicely. Well, it might have attacked the paint a bit more than I would have liked. Oh yeah. Oops. Guess the paint doesn't really matter, seeing as it gets so covered in oil that it's never going to rust anyway. Right, I put a little bit more effort into getting the worst of the oil off these ones first. For the motor, I'll do a solvent bath. Well, not a bath, I'll just give it a clean down in a bucket. Right, well that's that motor looking a bit better. Right, now that it's clean, I can see that I should have been oiling the bearings of this motor. They do sound kind of dry, although the bearings are still running nice and smoothly. When you buy one of these grease presses, it comes with different tips. So this is the one for like Zerk fittings, but there's another one of these tips with a point for doing exactly this kind of bearing. The only question is, where the hell is it? Looked everywhere. Anyone know where I put it? Anyway, let's get this air pump pulled apart. Okay, looks like a carbon vane type pump. Pretty simple. Nothing looks too horrible in there. Just give it a clean up and make sure these are nice and loose in their slots and put it back together. Bearings feel quite nice. As far as I can tell, this just presses out. I don't know what sort of bearing that is, but it obviously runs directly on the shaft. Still feels nicely lubricated, there's no play in it, there's no grit or anything in it, so I don't think I'm going to bother disassembling those, given the rotor are clean. These vane type pumps need to make a seal against the outer surface here. They're not spring loaded, so my guess is that they just use centripetal force to extend and make that seal. Now when I disassembled it, there was quite a bit of like built up sort of gunk on them and they were quite sticky. Now that they're clean, they look like they're moving nice and freely. So let's put it back together and see how it works. It's interesting that this thing's got like no stops to it anywhere. Next I'm going to need a very thin smear of Hylamar on the surface. When I pulled it apart, some of the gasket sealing compound had got onto some of these vanes, and maybe that also contributed to them being stuck in their slots. So I have to be very careful that the bead of sealants on the outside doesn't sort of squish on in and get onto the vanes. Does move a little bit of air. This is just an air filter. I already checked. It doesn't seem like it's blocked up. I could blow through it quite easily. Now I'm not really sure why they put an elbow in here, seeing as the air outlet pipe is coming straight down from the top. I think I'll just see if it's going to be long enough to connect it directly. Guess this doesn't really need to be sealed. It's only air blowing through it. I always seem to get the Teflon tape installed back to front as I twist it on. Right, with that air pump finished, I better check the maintenance manual and see if I've got any other scheduled tasks that I could do. Oh, wait a minute. Wrong maintenance manual. Transmission, SPF. Check the transmission monthly. Nearly. Okay, now on top of the DoAll instruction manual, there's also the US Army machine course in bandsaw operations, which has some pretty interesting information in it. So let's see what it has to say. Variable speed pulleys. Every 6 months, the variable speed pulley unit should be removed so that it can be washed and cleaned with a solvent. Check the pulley to see if the center sheath is free to shift sideways. Okay, so I guess the variator sheath mechanism should get 6 monthly maintenance. I better check my computerized maintenance program system to see when that was last performed. The good thing is this is all moving really nice and smoothly. So that's at least obviously been kept well lubricated. Okay, so the main shaft feels very nice. So does the The moving pulley also has nice smooth movement. I'm guessing that it's been damaged at some point and that someone's put this steel ring around the outside to try and maybe fix a crack or something. These are Bakelite or some sort of early plastic, maybe phenolic or something. I'm not going to completely disassemble this, I'll just give it a quick solvent wash. Doesn't seem to need anything else. I'm really glad to see that these movable pulleys don't seem to be in bad condition. You know, there's no bad ridging on them. They don't seem terribly worn out. That's definitely a good sign. You can also see here where that one adjustment screw's been touching this pulley. So while I've got that out of the way, well, that's the first issue solved. Nothing like a bit of angle grinder care to fix things. Throw a bit of oil on this before I put it back together. Right, well, I think I've got to the point here where I've reached maximum entropy. So let's start putting things back together. I've looked for 2 days and I still cannot find that pointed grease gun adapter. So what I'm just going to try and do, because these things have got some sort of a relief second opening below them, I'll open that as well and just see if I can pump grease through till it starts coming out the bottom. They seem to be quite big reservoirs of grease. I don't know exactly how they're done. Now looking down that lower vent, you can sort of see an internal structure down in there. So the cavity between the start of the vent and that internal structure, I guess, is what gets filled with grease. Oh, that's good. The grease is now visible through the bottom bunghole. Let's close this one up and do the other side. Okay, I've now got grease coming up through the bottom one as well. You can hear the bearings are much quieter. There is a bit more drag now with all that grease on them. Hopefully those bearings will now last for a long time. Pretty beaten up looking screw that. Right, well now I know that this is actually an original DoAll motor mount system, but it has been modified with these riser blocks. I've kind of got the dilemma that if I remove the 30mm riser blocks, I'm going to have to find 30mm shorter screws. I guess they're 3/8 inch UNC, and not going to be that easy to get here. Before, the pillow blocks were rotated 180 degrees, which moved the motor and everything too close to the weight mechanism. So I'm going to try and put the system back together, at least in the right rotation, but with the pillow blocks, and see where everything ends up. And hopefully I'll have enough adjustment available on the motor mount to still get this to work. Now in the pictures they show it using the middle hole, but I've got a feeling it's going to work better with this one. Don't exactly know why, but I'm going to give it a go. Right, before I go any further with mounting this, I need to work out whether the air pump's still going to fit. Right, well, a bit of mucking around, I think I've got everything set up in there. Good news is that the air pipe does seem to fit without the angled piece in it. So the next thing I need to do is just connect up that motor and see what the speed range is going to be. Well, that gland nut's got a completely deteriorated gland inside it, so I wonder if I've got any replacements. Yeah, that seal's completely disintegrated. Now, I'm going to need some sort of rubbery seal there, and luckily when I got my 3D printer, Bamboo Labs sent me a roll of TPU, which is kind of a rubbery plastic which can be printed. So I think what I'll try and do is draw up like a, I guess, 19 OD. The cable's got a 10mm ID, so I'll just quickly model up a seal and print it and see what that works like. Because TPU is such a flexible and soft filament, you can't use it in the automatic filament changer. You have to go through the single filament loading point at the back. One thing I really like about the Bamboo Labs printer is they've got a set of profiles for all of these standard materials, and so I don't have to muck around trying to work out what settings work. Just pick up a default, send it to the printer. It seems to have printed perfectly. However, I forgot to check which build plate I was supposed to use, and it sticks really, really hard to this one, so I'm going to need some help. So I read on the internet that if I put a little bit of India Pale Ale under this, it should help with removal. Oh yep, that helped. You know, I like that Bamboo printer so much that I've actually joined their affiliate program. And if you guys decide that you're going to give yourself a Bamboo Labs printer for Christmas, which is an excellent idea, I'm going to leave a link below, which is going to be an affiliate link that'll get you a discount, and they'll pay me a couple of % of the profit, and that'll be like a win-win for both of us. So have a look in the video comments below for that link. Okay, so I just went back and had a look at my disassembly video to work out which connector goes where. Black, blue, brown in that direction. Now there's no dedicated earth connection down in this junction box. I'm just going to put it back together how I found it, which was putting it under the cover there. Let's turn this on and see what happens. This isn't meant to be here. Okay, so obviously the top tire has walked off its wheel, and it looks like it got caught in the blade pretty badly, so it's got a lot of scars in it now. So I guess all I can do at the moment would be to clean off the old adhesive, put some new adhesive on both sides, and glue it back into place and remount it, and see if it'll work for a while I order new tires for this thing. While I'm in here, I might as well lube that upper bearing. You wouldn't believe how many grease fittings there are in the landing gear of a Boeing, like a 767 or 777. On an A-check, which is a sort of about every second month, as a mechanic, you'll spend like a whole 8-hour shift crawling up and over a landing gear, just greasing about 200 of these things. Definitely a job for young people. because there's really quite a lot of climbing and contorting yourself to even find all of the grease nipples. You're given a maintenance task card with a picture showing every location, but still some of them are not that easy to find. Now originally these tyres would have been made out of rubber. The rubber ones were definitely bonded on. These modern polyurethane ones, I think supposedly you don't need any adhesive. They should just hold in place with their own tension. Yeah, I haven't had great success with that. This is a pair that I bought new when I got this saw about 10 years ago, and yeah, after a while they did start coming off, so I have adhered them before, but I think they're kind of reaching the end of their life now. It is important to keep the tyres in good condition because these wheels are just cast aluminium and they have a crown on them to ensure that the blade runs in the middle and doesn't just walk straight off. So if you run without the tyre, the teeth of the blade will very quickly chew away that crowning and damage these wheels. You can see there's quite a few scars on these wheels from a long life. I've just been using contact cement for this job, but I do assume there's probably something that's more effective than this. I found the easiest way to get tyres on is just to use G-clamps to hold it in a couple of positions. And then it's pretty easy just to stretch and manhandle it over the rest of the wheel. Right, blades back on. Right, we're looking over at the air compressor. The pipe fell straight off, so that's too short. I'm going to need to do something to extend that. The second thing is, with that direction of rotation, the pump's going to be sucking rather than blowing. So that's easy enough to fix. That's just switching the inlet and outlet. Right, well, with the correct length belt, I think the whole system ends up way too low. The motor's nearly down on the bottom, and the air pump seems to be wanting to hit the side. Let me just switch back over to the shorter upper belt. Okay, with the shorter belt, let's see if this rides a bit higher. Oh yeah, that's looking pretty good. And now I can also use my power feed mechanism without it hitting on anything. You can adjust whereabouts that counterweight sits for more force or less force. Now at that angle, this might also work. I will need a hose clamp on it later, but just see if it sits on there now. Now the whole idea of the blower is just to keep the chips moving away from the line so you can actually see what you're cutting. Not exactly a blast, but it is now working. There was nothing really wrong with the chip blower except that it was gunked up and needed cleaning, and removing the angle adapter from the hose makes the hose work. Right, well that saw's back in service, pending blades, belts and tracking. Oh man, I went to the hardware store twice this week and I was just going to buy just some sort of a small brush, cut it up and bolt it on, but I forgot to, so that can go next week as well. By the way, my next Patreon members live stream is going to be on the 1st of December at 1300 Central European time, which is an hour after my video will go live that day. Hope to see you all there. I'm going to have to do the blade tracking, but that's going to be a different video. I've kind of run out of time to go through and measure the change in speed since moving the motor mount around. So I think what I'll do is I'll finish this video here. I've pretty much finished the maintenance, and once I've finished editing this video, I'll go through, measure the band speed, measure the range of speed, and if those belts are going to work, then I can order new belts and also order some new tires. But a job's not done till the tools are put away. Thanks a lot for watching.